Hello and welcome. Today's topic is very different from what we are doing these many days. These many days we are learning uh, something API. We learn writing the journal. So we are going through the several topics, several API namespaces in NXOpen, and we are looking at the different examples related to those topics. But this particular topic that I am going to touch today is mainly important uh, in a practical aspect. You might have experienced this many times when you have worked on assignments. So you might uh, have come across several type of errors, and you have also come across some errors very frequently. Very common type of errors you also come across very frequently. So this is the practical aspect, I would say, where you also understand or you try to find out the cause for that error into your program itself, because you written that program yourself, or maybe you taken help of a journal, whatever way you have managed to complete that program, and it causes an error. So definitely the root cause of that error is within your program itself. It There is supporting things from NX side are also required. For example, uh, you are creating extrude, but extrude direction and the extrude plane is same. So that time it's obviously that extrude won't be created. So you get an error. So that is the kind of errors you get from the NX side. It's not really wrong with the uh, your program, but you definitely need to tweak your program only, because from NX point of view, it's not feasible. And it's not practical even real even to expect some kind of output with that kind of conflicting inputs. So there is sometimes it lands in the NX, but most of the times the root cause for that error lands in your program itself. And even if you learn uh, programming, even if you learn writing different functions, even if you learn how to use the APIs, etc. But if you don't know how to handle these errors, then you are missing out on a very important aspect of being a developer, being a programmer. So this is what we are going to touch today. There are actually two or three different angles or different subtopics, I would say. Those are available here. I'm actually what I'm doing. I'm not keeping those topics different. Whenever means this topic can be called as the methods or the best practices to ensure that your code works in any situation. I mean, any situation means your code does not get fall into a error in any situation, because it is again not practical to expect that your code works in every situation. If your code is written for drawing, it will obviously not work in assembly. So that is not the perfect statement, I would say, to make. But the statement can be that your code is not uh, giving any errors. Either it is running and doing the expected task, or if it is giving you a message that for so and so reason it won't be possible to run this code on this scenario, on this part, on this assembly, whatever it is. Okay, so this is uh, what is the uh, approach, or what is this is what we shall aim for when we write a program. We shall write a program that works in all the cases. If there are any errors, it does not provide those errors. Rather than that, it gives us some message that we can understand, and then we can, as a user, actually I am saying, so instead of giving a error message to user, if my program is giving some meaningful information, warning, then that makes sense. Because if a user gets an experience of those kind of errors that he won't able to understand, then it is obviously he will not feel comfortable using your program. But instead of that error message which he don't able to understand, if your program gives some meaningful message, and with that he can get what's the problem, what's actually going wrong, and this program is not running, so that will help intact the confidence of that user into your program. So as a developer, user experience is something we have to also take care. On top of every aspect that we take care and ensure that our program is working and doing the same thing what it is expected to do. So this is something that we also need to take care, mostly user experience point of view. Okay, so this particular topic is divided into, I would say, three or four subtopics. First is going to be the base practice for writing your code. Then second is going to be the error handling. Uh, and then uh, if there are any situations which we cannot handle, then how we block those exceptions coming up. So that is the third subtopic. So definitely we are going to see each of them one by one, step by step. So I would start with the best practice. So writing best practice, I am going to talk about. Program writing, I am talking about. So how we go and write any email body, or if we write any article or any paragraph. So we follow some rules. Like for example, it is if it is English, then we ensure that there are no spelling mistakes, and also there are no grammatical errors. So this is very pure, very simple rules for writing anything, right? So similarly, there are some rules which definitely help uh, make our look our program good. Okay, so I will first start with code refactoring. Now, the meaning of code refactoring is we are actually r- restructuring the code in a way that looks good. We are actually improving the structure how the code is written. This helps us uh, keep the uh, reading behavior, or reading easy. So to keep the easiness in reading of the code. Why actually code refactoring is required? There are two reasons, I would say. I'm not talking about the kind of assignments that you have done so far. Imagine you are writing a code which is more than 500 lines of code. You're writing a program which is more than 500 lines of code, at least. So when you are writing journals, it is 50 or 100 lines at the max. But when you go and write too many functions into your journal, one main function and several other functions which are supported and called inside main function. So if you write that kind of code, then definitely this is useful. Now, coming back to the two reasons why code refactoring is required. Let's say if you visit your own code after 1 year or 6 months, not not that much duration. just 6 months or 1 year, you are revisiting your code. So what happens is that we have to recall what was the intention, how we have written that code, the way we have written it. So all of that you have to recall. And how you recall it, you definitely need to spend time on that. What you will do, you will, if you're not able to understand your own code, then you will definitely go and debug it line by line to understand why that particular logic is. Even most of the times it happens with me even now as well. I revisit something which I have done 5 years back, 6 years back, and I have to, and there is no documentation, there is no refactoring used there. Then I have uh, to dig it out. I have to debug it and understand why it was written like that. And it is actually the second reason is that if it is not written by you, let's say some team member has written that code, and now it's your job to take it further, develop it further, add some features to that program, something like that. You have to do it. Then it is more difficult because it is not easy to understand that code upfront. You need to spend time doing that. But if code refactoring is used, then it is like reading a paragraph, reading a book, which is very well written, everything covered step by step, every understanding, everything very like all the references are given with proper so that you can understand everything proper. You get the context right. So if you not get the context right, then you won't able to understand. So this is the code refactoring where it is used. This is where it is used, and it helps you understand that code. So in short, the advantages are it improves the readability. It also reduces the complexity. You might have written a very complex logic, but understanding that logic is very important. And if you understand that, you won't feel it is complex at all, right? So it reduces that kind of complexity even if you are written a complex code. And maintaining that code over the number of years is easy if refactoring is done. Let's say you have written several programs in your organization, and it's time for you to move out. For some reason, you are moving out. You are taking new opportunity, and then what happens? You know that there is something called knowledge transfer, and that can run for weeks and weeks, provided whatever you are doing, there is no proper documentation being made for that. And programming or scripting is something which is it is very hard to prepare that kind of documentation which explains everything in layman's term, why you have developed this program, for what reason you have developed, what is the logic used, what is the calculations, kind of calculations done. So all of that is very different to maintain or even create that documentation. So instead of creating that documentation, if you use refactoring, you don't need to create separate document. If there is a person who understands programming C sharp, he understands NXOpen, he can take over uh, your job or your codes very easily without you being spending time with him, sitting with him, and giving him the knowledge transfer. So that is what is I would call maintainability. You don't need to take care whether it will become black box once you leave it, once you left the organization, because if refactoring is something that improves readability and it becomes easy to maintain. It also makes the code simple and cleaner. Okay, then a little bit about dirty code and clean code. Now, this is actually a big topic for you, but if you adopt this, this is definitely going to help you a lot as a programmer, as a developer, because this is something that makes a good programmer. If you are a bad programmer, what you will do, you will do not follow the proper meaningful naming convention for variables. You will have some code written in some function, some other code written in some other function. There is no proper sync between two. There is no proper segregation between the code blocks within different functions. And if you are writing such kind of codes, even if you visit that same code in just 2 to 3 months yourself, you won't able to understand your own code. and this is how you become not good programmer. So good programmer is a programmer who follows this practice, keeps his code clean, simple, readable, and this is the method that helps you do that. So dirty code is the characteristic of a bad programmer, I would say. uh, Bad programmer is like you are a person who just started doing programs, you started writing programs, you don't have enough experience, you don't know how to plan your coding. Let's say you are doing assignment, so only one task, one assignment you are doing. But let's say if I asked you to club 10 different assignments together and write a code, so that time definitely the planning of how you write the code, what sequence you will follow to club all those 10 different requirements together. Also, all that comes into picture. So it is actually called management of the code. So you will go line by line, you will go function not line by line, you will go function by function. You will also you will also decide how you will go and write the variables. You will also ensure there are no duplicate variables. You can use the same variable if the same thing is being done multiple times. So this kind of thing is something called management. And uh, you will not hard code. So means specific name, specific value. So instead of having that, you'll have it unless until it is a very constant value. You will not mention the value itself. So that is also one part of mismanagement or not writing a poor code. Whereas clean code means it is easy to understand, read, maintain. Also, it is a predictable code. Means if you, let's say you have developed a very good program, and it is being used, uh, and it is become popular, it is helpful, everyone is liking using that, everything is doing good, but uh, user won't able to understand whether you have written the readable code, whether you have followed code refactoring or not. User won't able to understand. As long as he is getting good results, he will use your program. But let's say if you got a new requirements, of course, this is the obvious process that happens. If your program, whatever you have developed, it if it is doing good job, then you will definitely get the improvements because improvement is continuous process. You'll get some more requirements to add into the same program. But if your code, what you have written, it is not neatly written, then it will be difficult to add for you that those new requirements because those new requirements might conflict somewhere uh, with the objects or with the variables that you have used, with the logic that you have used. It will conflict somewhere in your code, and then that will make it difficult to include that new addition into your code. So this is also like your code becomes rigid, I would say, in that case. But if you follow code refactoring, your code becomes flexible. It means you can keep on adding requirements, keep on adding new features to that with easily. Uh, you can keep on adding new features easily into that code. This is how it becomes a predictable software development. This is how your code becomes agile, which is flexible enough to adapt to the new requirements. And if I have seen, maybe what I am talking is something not the near future for you. It might be little long term, uh, what I am talking about because you have just started. But if you understand the importance of this, you can help yourself not getting into trouble in future because I have seen this many times that because your code is that rigid, it is not developed with the best practices, then even if it is a very potential program to have, but it dies with time. It dies means the importance of that being uh, decrease importance means usage is gradually it is decreased because you are not able to keep it up to date. you're not able to add new features. And eventually, as you it is it because of it is rigid, it comes to the stage where you cannot make more changes to that, or it becomes difficult to change that code, change that program, and eventually you have to scrap it. I've seen many such cases, even in my own experience. I also not was following this to the T. If at all I was following, if at all I'm pushing this to the team that I used to work with, but still, if something is getting missed out, and this is something that I have faced myself. So this is what can happen to you worst side if the code refactoring is not used. Now, uh, let me talk about some signs of clean code. What actually is clean code mean? What is actually the uh, the factors uh, that validates that you are using code refactoring? So we have seen some examples, only few, but we have seen where we have used couple of functions or more than that besides the main function, right? But uh, uh, if also we have seen several for each examples which actually uses us. So this for each functions or whatever other functions that we have seen, those examples we have seen. So main job of having that function is if there is repetition of code that we manage to avoid with that function, right? Or with that for each loop. So if your code has no duplicate code blocks, which is a good sign. Each time you have to make the change in your duplicate code, you have to remember to make the same changes every instance. If there are several duplicates of the code block that you have, so it is maintaining is difficult. So if you do not have any duplicates, it means it is a clean code. And also minimum number of classes. So we have seen only one class. We have worked with only one class so far. There is a class, there is main function, and there are several functions. This is what is the pattern we have followed. But if you gonna write the program which is very lengthy, lot of features, lot of different things you are going to write your program, then your number of classes may increase. But it is ideal to keep those number of classes minimum. Less code means less stuff to remember, less stuff to modify, less stuff to code and test and correct. Also less maintenance, less bugs, and it is a simple. So if we keep the number of classes less, it is uh, it is a sign of clean code. But it is again based on requirement. Uh, there are a lot of times I myself has seen we actually write the programs which the development goes around 6 months or even sometimes year. And if that kind of developments uh, need to actually write several classes which handle different things. But we have to also ensure that we are not overlapping the different classes to any two classes. We are not also having duplicate code. And those are, though there are many classes we have created, but there is solid reason why they are created. We cannot just create number of classes just for sake of having them. Also, the another sign is that your code does not have any unnecessary code or unused code. For example, mark ID. I would say it is unnecessary unless and until you understand why it is required in your code. Again, if there are any parameters in a builder example that you have, which is not used, which is not mandatory, and you can ignore that straight away. So that is, I would say, unnecessary code. And again, if you do have unused variables, so you have declared variable, but no value is assigned. Value is assigned to that variable. That value is not used at all. That variable is not used at all. So that is also sign of uh, sign of that is also sign of extra code. So it is not, so which is sign of dirty code, I would say. So if these are there, if there is no duplication, there is no unused code, there is no unused variables, it means that your code is clean. Then the techniques. Now the important thing, how you ensure that you are following code refactoring and it is uh, uh, but there should be some steps, right? So how to follow the code refactoring? There is actually a lot of stuff you will find about code refactoring on internet. Even you will even find books on this. You don't need to get into that much detail. So whatever I have like explained you so far is just to give you the idea how important it is to follow to become a good developer. I want everyone in our community is a good developer who who follows the programming best practices, and his code is always clean, neat, simple, free of bugs, etc., etc. And that's why I wanted to give you this background, because I want you to know the importance of following coding best practice. If you follow this, you will definitely stand out from other programmers in your team. So whenever you get into the full-time role of NXOpen developer, that time this is something that will help you to stand out from others, other peer members in your team. Now, uh, there are only few steps that if you follow, you are good at it. You don't need to read too much things about code refactoring or best practices. You just need to follow these 4 5 steps. That's it. Following a naming convention. Maybe you have seen me, I'm using some short names for variable. Even my class names or function names are not that consistent, meaningful. But that is just to because I'm doing that for the training purpose. So all those examples are training examples. So I'm focusing on the content that I'm uh, providing you. I'm not focusing on writing the meaningful variable names. That's why you have seen me not following it. But when you write the program that you are on going to maintain it, develop it further, it makes sense you write the meaningful names for everything, whether it is function names, whether it is variable names. For everything, you will follow a meaningful naming convention. For example, you do have a variable for the diameter dimension. So you can have the name diameter dimension. Of course, we cannot have space in between. So you write it without space, but have it meaningful, right? Having it short is not useful. You can have it lengthy, but have it meaningful. So that is what is required, because then by that long name itself, you understand what is that meant for. If you do have 20 25 variables in your program, that time by reading that variable name itself, you understand what is the purpose of that and what is the object it is. So follow the meaningful name. Lengthier is always fine. It should be like that. You understand the exact purpose, exact meaning of having that variable there by its name itself. So this is what is I mean by meaningful names. Also, you know that with double forward slash, we can comment our code. So it is best practice to comment as much as possible. I would say every line you write, you add a comment before that. Initially, to start with, you have to do it, because this will help you get habitual doing this. And then later on, if there is very simple line of code that is easy to understand, you can skip writing the comment there. But to start with, you must write a comment to each and every line of code. That will help you to get to develop that practice, because it explains the code. And to whom you are going to explain? You are going to explain yourself only. You're not going to explain to someone else. You have to understand your code. That is the starting point. Okay, then third point is formatting. Actually, you don't need to take care of formatting as you're using Visual Studio. So that formatting, the tabs in between the lines, and all of that spacing is taken care in most of the cases. So this is the third point. And then last but not the least is handling the objects and data structure. Means that you do not have unused core or unused variable. Visual Studio also gives you that idea that there is if there is a code, if there is a variable which is not used, so you get that highlighted. They also you ensure that there is no duplicates, and you also create the functions whenever needed to avoid the duplicates. So if you follow this just 4 steps, you are done. This is more than enough to follow code refactoring. But as I said, uh, there is a lot of importance of doing this. If you do this, then you are always a good programmer, and there are a lot of benefits of this, because when you get into this role full time, you'll be developing many different small and big programs. So that time it becomes very useful to follow the code refactoring. So to ref, uh, to summarize one more time, following naming conventions for functions and variables, then use of comments as much as possible. Almost every line you write a comment to explain yourself that what you are doing at this line. Again, formatting, which mostly taken care by the Visual Studio itself, and then no duplication of code, no unused variables, no unused code. That's it. So these are the only 4 to 5 techniques that you have to remember for code refactoring. Now, definitely you are going to get an assignment where you have to do the code refactoring. I have only explained you the theoretical part, but it's not that difficult, right? You can comment your code, you can use meaningful names to your code, you can think of what is unnecessary and you can remove that. You can find out what is the duplication of code. So it's possible. It is actually, you don't need to have the practical example from my side. You are anyway going to get the assignment to work on this, but these are more or less the practical pointers only, which you can easily understand and adopt. So this is about code refactoring. Now there is couple of more topics here, subtopics that I have already told you. Those is one is error handling, and uh, another is exception. Sorry, I think I am missing out. Yeah, so one is exceptions. So there are several kinds of exceptions that you can come across, and another is how you handle them. So first is you have to understand why that exception is, what is the reason for that, and then if you understand reason, then you can handle it or you can resolve it. Right? So it is that simple. So that we will go and see in tomorrow's session. Uh, I do also have the the short uh, appendix, I would say, that will help you for following these best practices. So I'm anyway going to share that with you so that you get an idea what I mean. Uh, yeah. So this exception handling and errors we will see uh, tomorrow, uh, and that time we'll also see some examples of this. So that's it for today. we are done with today and look for the assignment on this topic from me.